Tectonic lakes. These form when sections of the Earth's crust crack or sink over millions of years, creating deep depressions that fill with water. Lake Baikal in Siberia is the most famous example, sitting inside a rift valley where two tectonic plates are slowly pulling apart. That process has made it the deepest lake on Earth, holding roughly 20% of the world's unfrozen fresh water.
Volcanic crater lakes. When a volcano goes dormant, its crater can collect rainwater and form a lake over time. These are often strikingly circular and sit at high elevations. Crater Lake in Oregon formed after a volcano collapsed about 7,700 years ago and is one of the clearest lakes in North America. Some crater lakes sit above still active systems, making them highly acidic and chemically extreme. Glacial lakes. Moving glaciers carve and scrape the land beneath them, and when they retreat, the hollows they leave behind fill with water. Much of Canada, Scandinavia, and the northern United States is dotted with lakes formed this way at the end of the last ice age. The Great Lakes of North America are largely glacial in origin, shaped by the slow advance and withdrawal of enormous ice sheets.
Oxbow lakes. Rivers bend and curve over time, eroding one bank while depositing sediment on the other. Occasionally, a river cuts a new, shorter path, and the old curved section gets left behind as a crescent-shaped lake. These are calm and shallow, and because water no longer flows through them, they slowly fill with sediment and vegetation over centuries. Floodplain lakes. These form in low-lying areas beside rivers when seasonal flooding leaves standing water behind as levels drop. Many expand dramatically in wet seasons and shrink in dry ones. The Tonle Sap in Cambodia is a striking example, growing to several times its dry season size when monsoon rains cause the Mekong River to reverse direction and push water back into it. Landslide lakes. When a hillside collapses, the debris can block a river valley and trap water behind it almost overnight. These lakes can appear within days, but the natural dam is usually unstable. If it fails, the flooding downstream can be devastating. After the 2008 earthquake in Sichuan, China, dozens of these lakes formed and required urgent intervention to protect nearby communities. Aeolian lakes. Wind erodes loose sediment in dry regions, gradually forming low-lying basins. When these sit at or below the water table, groundwater seeps in and creates a lake. Parts of the Sahara and Australia have lakes that formed this way. In arid climates, they often dry out seasonally, leaving behind flat salt pans when the water evaporates. Karst lakes. Limestone and dolomite dissolve slowly when exposed to rainwater, creating caves, sinkholes, and underground channels over long periods. When enough rock dissolves near the surface, the ground collapses and fills with water. These lakes often have no visible inlet or outlet because water moves through the porous rock beneath them. The Plitvice Lakes in Croatia are a well-known example of an entire landscape shaped by this process. Meteorite lakes. A large meteorite impact creates a crater that can eventually collect water. These lakes tend to be roughly circular and surrounded by rock altered by extreme heat and pressure. Lake Manicouagan in Quebec is one of the most recognizable, forming a near-perfect ring visible from space. The original crater is estimated to be over 200 million years old. Relict lakes. Some lakes are remnants of much larger ancient water bodies that have since shrunk due to shifts in climate or geography. The Aral Sea, once one of the 4 largest lakes in the world, has shrunk dramatically over the past 60 years due to irrigation projects that diverted its source rivers. The Caspian Sea, though called a sea, is technically a relict lake.
the last remnant of a vast, ancient water body that once covered much of central Eurasia. Endorheic lakes. Most lakes drain into a river that eventually reaches the sea. Endorheic lakes have no outlet at all. Water enters through rivers or rain and leaves only through evaporation. Because of this, minerals and salts accumulate over time. The Dead Sea and the Great Salt Lake are both endorheic, and their saltiness can reach levels many times greater than the ocean. Meromictic lakes. In most lakes, wind and seasonal temperature changes cause the water to mix from top to bottom at least once a year. In meromictic lakes, this never fully happens. The deeper water stays permanently separated, usually because it is denser due to higher mineral content. Without mixing, the bottom layer loses oxygen and can preserve organic material for thousands of years, creating a kind of natural archive within the sediment. Saline lakes. Any lake with significantly elevated salt concentration qualifies, regardless of how it formed. Some sit atop salt-rich geological formations, others formed where seawater once intruded. Lake Assal in Djibouti is one of the saltiest bodies of water on Earth, sitting in a volcanic depression below sea level. Despite the extreme conditions, many saline lakes support specialized life. Flamingos, salt-tolerant algae, and brine shrimp often thrive where little else can. Proglacial lakes. These form at the edge of a glacier, held in place by either the ice itself or by ridges of debris pushed ahead of it. As glaciers melt, these lakes grow. If the dam suddenly breaks, the released water can reshape entire valleys in hours. With glaciers retreating across the world, proglacial lakes are becoming more common and pose growing risks to communities in the Himalayas and the Andes. Reservoir lakes. When a river is dammed, the water backed up behind it creates an artificial lake. There are now tens of thousands of these across the world. Lake Kariba, Lake Mead, and the Three Gorges Reservoir are among the largest. They serve critical roles in water supply and power generation, but their creation has also flooded valleys, displaced communities, and altered river ecosystems in ways that continue to be studied.